Hi, my name is Mr. Woodsy. Today we'll learn about exponential models with the help of my friends Mr. Payne and Miss Bling. So this whole thing started when I felt unwell. Cough, cough, cough. I decided to visit my doctor, Mr. Payne. He listened to me patiently and gave me his verdict on my health. Cancer, he said. Exponential growth on cancer cells. Number 1. Mr. Payne needs to know the rate at which the cancer cells are replicating. The certain type of aggressive cancer cell found in Mr. Woodsy's body, a favorable growth medium, doubles in population every single day. Given that there were approximately 20 cancer cells to start with, how many cancer cells will there be in Mr. Woodsy's body after a month? Problem number 1. Explanation. The first step is to analyze the information given in the problem. How to solve? First, we have the formula A equals PE to the KT power. Now, A represents the end amount, P represents the initial amount, K the rate, and T the time. In the context of the problem, we are searching for A, and for P we know that the initial population is 20. We are searching for K, and for T the time we know is 30 days, a month. The second step is to find K, the growth constant. To do this, set A equal to 40, because the double amount of P, the initial population, is 40. Now, plug in the rest of the information, such as P equals 20, the initial population, and for time, we use 1 to represent 1 day. Then we solve for K. Find K, the growth constant. To do this, we use the formula A equals PE to the KT power. Now, A is equal to double of 20 because the cells double in population in a single day. So, we have 40 equal to 20 E to the K power. Now, divide both sides by 20, and we end up with 2 is equal to E to the K power. We take the natural log of both sides, and we end up with natural log 2 is equal to natural log E to the K power. Now, through a property rule, we move the K from the exponent position to the constant position. So now it's natural log 2 is equal to K natural log E. Natural log E cancels out, so as a result, we have natural log 2 is equal to K, our constant. The third step is to find A. To do this step, plug in all the given information and the newly found K value. Solve for A. Find A, the end amount. We use the formula A equals PE to the KT power. Now we plug in the values we already know from the given problem. A is equal to 20E to the natural log 2 times 30th power. Use the calculator, and in the end we end up with A is equal to 2.147483648 times 10 to the 10th power. If we multiply out the 10 to the 10th power, we end up with something about 21,474,836,480, which is about 21.5 billion cancer cells. Problem number 1, solution. By using the calculator, A is equal to 21,474,836,480, which means in the context of the problem, Mr. Woodsy will have about 21.5 billion cancer cells at the end of 1 month. Problem number 1, relevance and implications. Exponential growth can be used to predict and calculate the growth of cells. It is useful in the medical field for doctors because this helps them predict the number of harmful cells, which will aid them in determining the dosage of radiation exposure or amount of medicine a patient will receive. It can also aid in scientific research about the growth of bacteria colonies on petri dishes. I refused to die. Medical costs became my next issue. I quickly told the bank that I needed a loan. Miss Bling began spitting out all these big numbers. Exponential growth on money. Number 2. Mr. Woodsy needs a loan from Miss Bling to pay for his radiation therapy. The bank agrees to loan him $150,000 with a 3% interest compounded continuously. How much money is Miss Bling expecting from Mr. Woodsy to pay at the end of 3 months in a full one-time payment? Problem number 2, explanation. Number 1, first analyze the given information. How to solve. For the formula, we use A equals to PE to the RT power. A represents the end amount, P the initial amount, R the rate, and T the time. In the context of this problem, we are searching for A. P is equal to 150,000, R is equal to 0.03, and T is equal to 3 months. The second step is to find A. To do this, plug in the given information into the formula, then use a calculator to solve the equation. The answer is A is equal to 164,126.1426, which is approximately A is equal to $164,126.14. Find A, the end amount. We use the formula A equals P times E to the RT power. We plug in the information. A is equal to 150,000 times E to the 0.03 times 3 power. We use a calculator and we get A is equal to 164,126.1426, which is ultimately $164,126.14. Proof for the interest formula. Proof. The general compound interest formula, A equals P times the quantity of 1 plus R over N all to the NT power. The formula A equals PE to the RT power is derived from A equals P times the quantity of 1 plus R over N all to the NT power. The work. The general compound interest formula, A equals P times the quantity 1 plus R over N all to the NT power, is the basis for this proof. Now we use M, and M is equal to the N over R, which is the reciprocal of R over N. Now we substitute R over N for M in the general equation. So A is equal to P times the quantity of 1 plus 1 over M all to the MRT power. Now, using a property, we separate the exponents. So now we have A is equal to P times the quantity of 1 plus 1 over M to the M power and all of the quantity to the RT power. Now we need to find something to substitute 1 plus 1 over M to the M power. We do this by using the limit. The limit as M approaches infinity, which is without bound, of the 1 plus 1 over M to the M power is equal to E. And thus, we can substitute 1 plus 1 over M to the M power with E, and we have A is equal to PE to the RT power. Problem number 2. Relevance and implications. Exponential growth can be used to model interest rates. In application, banks rely heavily on this method to calculate money. Basically, by understanding how to use exponential growth, you can discover if using the interest formula compound continuously or quarterly or any other way is the most beneficial financial plan for you. Finally, my treatment began. After lots of sleep, drug tests, and reports, I became a new man. By understanding exponential growth, it saved my life. Now I have a cool best friend and an awesome girlfriend. Thanks for watching. By Samantha Lynn.